Hi everyone, my name is Faris. I'm a productivity engineer from Tiong Seng Contractors, part of Tiong Seng Group. With me also in this call, I also have one of my supervisors, Tiong here. If you have any questions, he or I will try our best to answer them. So yeah, so we post two challenge statements. One of them is the radiation cooling solution, basically passive radiative cooling. And the other one we will talk a bit more later. So background is that in Singapore or almost anywhere right, cooling is a major driver of electricity consumption and demand, right? Air conditioning becomes dictates a large amount of your building's energy consumption, and for that, building owners have been trying to, well, there has been a lot of ways to try to lower the temperature of a building, right? In Singapore, temperatures have gone up by, I believe it was 2 degrees, annual ambient temperatures have gone up by about 2 degrees over the past, I think it was 30 years. I can't remember, something along those lines. Yeah, so our challenge today is something to do, is to solve that problem lah. And the technology we are interested in is something known as passive radiative cooling. Okay, a bit of background. Granted, myself and Tiong, we are in the construction industry. We don't know that much about what this technology, how it works, but we've done a bit of reading up, and so just a bit of description about it. So radiative cooling basically has to do with the reflection of a very specific wavelength of infrared radiation back into space, right? Essentially it uses space as your heat sink, right? I believe it's about 8 to 13 nanometers, this very specific window of infrared radiation that to send it to space and use it as our heat sink, right? Any other wavelength of heat, usually what happens is that our atmosphere will just reflect it back to us, and you don't really get much change because your ambient temperature is already so high. So there's not much you can do. With radiative passive cooling, what we found is that, or rather what we know of is that you can achieve temperatures as low as 5 degrees lower than your ambient temperature. Basically mean that a certain element that is coated with, or rather that has radiative cooling properties, will be like 5 degrees lower than just the air around it, right? So that's quite a big benefit that we hope that we can work with somebody to try to achieve for our buildings. And from there, we are looking to, of course, your end game is, like I said at the start, we want to lower the cost of cooling of buildings in Singapore, right? So the things to note for our solution is that it should be most effective during the day. As of right now, your normal radiative cooling, which technically all materials can do, are mostly effective at night, right? That's because in the day, there's too much light, there's too much heat source for there to be any substantial benefit. So that's the challenge that we wish to overcome. Okay, so to have a solution that is, instead of at night, is very effective in the day, whereby we are able to reflect this 8 to 13 nanometer wavelength back into space. And because we are a construction company, we also understand that it's one thing to have a radiative cooling solution. It's another thing to integrate it with what is currently in practice. So in practice, what I mean is your typical concrete, steel, glass, right? These are your main surface materials for buildings in Singapore. So if we can integrate these two together and grant our facade and grant our existing materials with passive radiative qualities, that would be great, and naturally suitable for tropical climates in Singapore. Now, one of the key things about passive radiative cooling is that you are you are supposed to direct it back into space, right? You are supposed to aim it generally upwards, or at least in a direction that does not that can reach space, even if not vertically upwards, right? It needs to have a line of sight per se to reach space, as space is essentially your heat sink. Anywhere else, if it goes back into ambient, if you shoot it back at a neighboring building, you're defeating the purpose. So, and one of the things that we mentioned is that your a layman thought will immediately be, okay, that probably means that I can only put it on my roof, but that's not necessarily true. We found that you can have these materials positioned and developed a certain way such that even though it's not on a horizontal surface, it still reflects upwards. And if not, then existing regulations would take into effect, right? And one of them that we found that might contravene with this technology, may or may not, we depends on how the final solution works, is that the government says that any, like the solution must not sort of, like I said, you can't shoot the heat back at another building, right? The direct words that used that you can see on the slide is that it does not result in loss of amenity to occupants of other buildings in the vicinity of that building. If you're gonna shoot straight, if you're gonna aim it straight up, you're fine. If for some reason it's on our vertical faces, then clearly we cannot have this heats. We cannot have this heat being dissipated at a neighboring building. So that's one consideration for our partners to think about. I believe that's it. Yeah. So just to recap, uh, best is that we can apply it to existing materials, right? So concrete, steel, glass. Practicality is definitely important, and as with all things, cost. Yeah. So that is it for radiative cooling solution.
Thank you, Faris. Really fascinating that we could potentially shoot heat waves into space. We have a first question for Cheng Pang. May we know the technology or solution that you're looking for? Is there any application limitation? Uh, Meaning, if you want to apply this technology on glass or concrete, does it need to be before the construction materials are set up? Like basically, what doing is it being applied in the existing building, or it needs to be applied for a building that is still being built?
Mm, at this stage, you could almost say that we are still at a proof of concept kind of idea. So I think it would be going a bit further and beyond to say, okay, we need something that we can apply to existing buildings, because that really limits the how much leeway we have to work with. So if we can, for now, I think best it would be fine if we can just, if we still stick to buildings that are still under construction. So that would be a lot easier for us to work with, a lot easier for us to do test bidding, and a lot easier for us to make sure that everything can set up nicely, everything will work correctly, rather than to try to apply onto something, a building that's already standing, and then getting in the way of that said building and its tenants.
Mhm. Yeah. So
Yeah.
for the application of this solution, right? Which area do you think is uh, the most the first area that you can target first? For example, the roof,
Yeah.
the glass facade. What do you think is the first area to target first?
Mm, yeah. So naturally, like I said, lowest lying fruit lah would be on the roof of buildings, right? Yeah. But ideally, we want to actually apply this onto walls. So basically, vertical, larger surface areas lah. So which is usually your walls, your vertical faces, and not your roof faces, because that would be not say easiest, but I think that is pretty much we've seen cases of that happening. So ideally, we would like this to be done on vertical faces such as our walls, our columns, and other facades.
Okay. Yep. The next question. Sorry, give me a while. So have you tried any of such solution, and what are the what what do you foresee as the potential challenges or limitation?
No, we have not tried. I mean, generally, you know things. What is known is things like, okay, white surfaces tend to stay cooler and all that kind of thing. But for this case, what we are aiming for, what we believe is possible, is that we can go even lower on and gain or reach even higher benefits than just sort of existing techniques like using white paint and just and maybe even aiming it at a certain angle. But yeah, what we are looking is probably a bit higher than that. But as of right now, no, we have passive radiative cooling is not something that we are using right now.
We don't have any other questions.